Welcome to the Techie Tessie channel. My name is Tess, and today we're going to be covering some standard algorithms. This is the second part of our data structures and algorithms series, so if you haven't watched our data structures video yet, I'll link it above. So today we're going to be talking about algorithms, and this definition of what an algorithm is comes from the book Codeless Data Structures and Algorithms. An algorithm is a method of solving a problem by applying a sequence of steps that will always work to solve the type of problem it was designed to solve. And now our last video was on data structures, so if you haven't seen that already, I'll link it above. But this is how data structures and algorithms work together. Data structures organize the data that algorithms work upon. So today we're going to be talking about a specific type of algorithm called sorting algorithms, and there are three main types we're going to talk about today: bubble sort, insertion sort, and selection sort. I'm going to briefly describe what each of these sorting algorithms is, and then afterwards I'm going to show you some animations of them being used. So the bubble sort repeatedly swaps adjacent elements if they're in the wrong order. Insertion sort has data split into a sorted and unsorted part, and values from the unsorted part are picked and placed at the correct position in the sorted part. And the selection sort repeatedly finds the minimum element from the unsorted part and puts it at the beginning. So this animation is going to be a bubble sort. As you can see, we have some data here, and it's clearly not ordered. We have small values, larger values, smaller values, and we want to sort it from lowest to highest. So once I click this play button, you'll see how the bubble sort works by comparing two values next to each other and swapping them around if they're in the wrong order. And there's also some pseudocode down here that you can follow. So as you can see, if it compares two values, and if they're the wrong way around, they get swapped. And it continues to do this throughout the entire data until we have our desired output. See, once it's gotten to the end and it's still not in order, we keep going until it is, comparing each value to the one next to it. This website is called visualgo.net, by the way. It's very useful for visualizing different algorithms. I also urge you guys to maybe take a screenshot of this pseudocode and try writing it in the language of your choice. As you can see now, we're starting to get more of a pattern from low to high. And these data points marked in orange are the ones that are complete. And there we have it, all the data sorted from lowest to highest. Next we have the insertion sort. So as you can see, we have this data here, but we're also taking data out and placing it back in the correct position. So instead of the bubble sort, which we swap items, we're physically taking items out of the data structure and putting them back in once it's been sorted. So start having a think about what the different advantages and disadvantages of each of these sorting algorithms is, because obviously we have 3, which means we have different uses for each. And I'll talk about them at the end, but since you have the chance to see them here, think about how with the bubble sort, we just had a single data structure and we're swapping items. But here we're taking elements out of the data structure and placing them back in, and what implications that could have. Speed it up a tad. I think you can tell what's going to happen, so speed this last part up. And there we have it. Lastly, we have the selection sort. So here we're saying that the value at the beginning is the smallest, and we're going to go through all of the data, and if we find one that's smaller, that becomes the new minimum. And we place it at the beginning. So we go through the entire data, and each time we find the next smallest number, we move it to the front. So it's similar to the bubble sort in that it swaps values in the same data structure, but it doesn't swap two next to each other. It swaps whatever is at the beginning. I think this is the most human example of how you would sort something. If you had, say, a line of grapes on the table, and you'd instantly just pick up whichever one was smallest and put it at the front. And there we have it. The advantage of the bubble sort is that it uses a singular data structure, and the disadvantage is that it takes many steps to complete. In the worst case scenario, if you have 4 items of data, it'll take 16 steps to complete, so 4 squared. There's a way to measure this, which is called big O notation, and I'll make a whole separate video about that. An advantage of the insertion sort is that it performs well on small amounts of data, but a disadvantage is that temporary storage is required. And this was shown in the animation when we had to take data out and put it back in to the original data structure. When you take it out, you have to store it elsewhere, and this is a disadvantage. An advantage of the selection sort is that it also uses the singular data structure, like the bubble sort, but a disadvantage is that it has poor efficiency on large data sets. I hope you found this video helpful. Keep the code coming, be sure to like and subscribe, and I'll see you guys next time.